Hello, friends. So I'm coming to you to talk a little bit about squares and stuff. So when you square something, that is the same as multiplying it by itself. So 7 squared is the same as 7 times 7, which is 49. Notice that we don't write the x. We don't want to write 7 times 7 like that because that x could be confused for a variable. We want to start using parentheses to mean we multiply. Okay, another thing here, 6 squared is the same as 6 times 6, which is 36. 1/8 means you take 1/8 and multiply it 2 times. So it means 1/8 times 1/8, which equals 1, because remember with fractions, you multiply straight across the top and straight across the bottom over 64. So the base, when you have squares, the base tells you what you're multiplying, and the exponent tells you how many times you're multiplying it. Okay, so a square root is going to be opposite. You're figuring out what was squared. So in this case, okay, square root is the opposite of squaring something, a number. It tells us what number was squared to get the number under the square root. Okay, so in this case, we want to say what was squared to give us 25. That's what we're saying right there. There's a few ways you can do this. You can go on to a calculator and use the square root button. It's on all calculators. Or if you know what was squared, you can kind of run through the perfect squares down here. So in this case, I'll show you on Desmos, because Desmos is awesome and super helpful. So we go to Desmos, and then we can just type in the square root button, and then 25. And it shows up, it says 5. So 5 is what was squared to give us 25. So that means the square root of 25 is 5. And technically, it could be a positive or a negative 5, because negative 5 times negative 5 is 25, and 5 times 5 is 25. We won't worry about that right now. So our perfect squares are things that you guys should know. So think about trying to memorize these if you can. If not, it's okay. You'll get it eventually. No big deal. So perfect squares are like when you take each of these numbers and square them. So 2 squared gives us 4. And then that means that the square root of 4 is 2. It kind of works that way, forward and back. 3 squared, whoops, not to the third, squared, gives us 9. And then the square root of 9 is 3. 4 squared is 16. And then the square root of 16 would be 4. 5 squared, we know now, is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. So square rooting any of these would get us back to the number that was squared. So the square root of 36, over here we can see that 6 is what was squared to give us 36. So the square root of 36 is 6. And 100, over here you can see that 10 was squared to give us 100. So the square root of 10 is, or excuse me, of 100 is 10. Okay, so now we're going to talk a little bit about rational and irrational numbers. Okay, you guys got to know the difference between the two. Okay, and what helps us is knowing what a repeating decimal is and a terminating decimal. A repeating decimal is, sorry, I'm going to find my text. There we go. A repeating decimal is just what it sounds. It's a decimal that keeps going without end. And it has a pattern. So examples of this would be 0.3333333333 repeating, or 0.45454545. It's got to have some type of pattern to it. Okay, that's a repeating decimal. A terminating decimal is a decimal that ends. So that would be like 0.5 or 0.25 or 0.625, any of those. It's a decimal that ends. Okay, and the reason that we're talking about this is because that helps us tell the difference between a rational number and an irrational number. A rational number, you got to think rational, fractional. So a rational number can be made into a fraction. So this means it also, if you see a decimal, a rational number is a repeating or terminating decimal. So it's a decimal that keeps going without end, or has a pattern, or a terminating decimal, a decimal that stops. Okay, so down here we have numbers like 3/10, 2/3, and all of those. Okay, so we got to identify if they're rational or irrational. We'll talk about irrational in a second. 3/10, if I were to divide 3 divided by 10 to figure out what decimal it would be, I would get 0.3. Since that is a decimal that ends and it's a fraction, I would call it rational. 2/3, if you would divide 2 divided by 3, you would get 0.666 repeating. And since it has a pattern and it repeats like that, we would call it rational. Now the square root of 25, I have to figure out what that is first before I actually go ahead and classify it. Square root of 25 is 5. Since that's just a regular number, and I can make that into a fraction, 5/1. I could also call it a terminating decimal, 5.0, however, but this is a rational number. An irrational number is a number that it doesn't repeat, so it's a non-repeating decimal that never ends. A classic example of this is pi, which is like 3.1415, 29, etc. So pi, I know there are different patterns in pi eventually, but there isn't a consistent pattern. So it's a non-repeating decimal that never ends. Another example would be if you took like the square root of 2, you would get this crazy decimal. Okay, and we can do that right now. We'll go to our friend Desmos. So let's change this 25 to a 2. Look at that. 1.4142. There's no pattern. Keeps going. So we would say that's definitely irrational. Now let's take the square root of 11, which is what was on the examples below. Oops, I went too far. Square root of 11. Oh, look what that is. The square root of 11 is 3.31662479. So that's definitely irrational because it's a decimal that just keeps repeating and does not end. Okay, so rational fractional, a number that is rational can be made into a fraction, or it's a repeating or terminating decimal. And then anything that does not repeat and just keeps going is irrational. Think about pie, yummy, delicious pie. So these are all the different types of numbers, and we'll go into it further, but for now, you guys got to know your irrational numbers. We also have integers, which are the negative numbers, including 0. Whole numbers are all the numbers that are not negative and 0. And then natural numbers are your counting numbers, like the count from Sesame Street. 1, 2, 3, right? Okay, so now we have to classify these as rational or irrational. We already know square root of 11. We just did that one. That's definitely going to be irrational, okay? Because it's that 3.31. It just keeps going. -5, if you look back on our chart here, is an integer. It's a negative number. And negative numbers can all be made into fractions. -3/1 or -6/2. That's the same as -3. So those are all going to be rational numbers. So anything that looks pretty traditional, oh my goodness, oh yeah, I circled the right one. That's rational. And this one's a fraction already. So since it's a fraction, any number that's a fraction is automatically rational. I apologize we didn't get to this in class today, and that's all I have for you. So thank you for watching. I will, send a message out. You don't need to send a summary, but it'll help you get the homework done. Have a great day, you guys, and I will see you on Monday.